Okay, thanks a lot. Hopefully you could see my screen. Video and audio are working. In theory, everything should be good. It's not like we don't do Zoom every day of the week. So let's get started. If you have any questions, I've got the Telegram chat and I've got the Zoom chat up. Just let me know and I will answer your question. This is, I have slides here that we'll share with you, and I'll be going through demos, but we could stop and change things at any time. This is your time, so just let me know. I've got my contact information in the slides, so if you have more questions, you want to see the source code, you want to see different demos, feel free to reach out to me. I'm online more than I should be. Today we're going to be doing continuous SQL. And why this is important is in machine learning and everything else, you can't wait to once an hour or once a day for things to arrive. As events happen, as new data comes in, you have to react to it. And I'll show you how you can connect to these events in something that pretty much any data scientist or data engineer knows, and that's with SQL. And I'll show you a little bit also around the other parts of the Apache streaming stack that lets you use open source to be able to create these pipelines, get the data you need for training, get the data that you need to apply into classifications or the data that's used as correlated data there. And we'll bring that in real time and show you the different ways you could bring in that data, how you connect it, and everything about that. And then you could see where lots of different places we can plug in the machine learning, and I'll show you different spots where people tend to do that, give you some of the best practices there. I've got a lot of in-depth articles at my Data in Motion blog, and I've got a lot of source code examples on my GitHub. So definitely reach out and take a look there. You will find some new stuff there. I also do some writing at DZone. Again, I'll put to make sure the slides are available. I'm sure they'll do that. And all my information is there if you need me for another talk or you just want to see something deeper here, whether it's IoT, making machine learning pipelines accessible regardless of where they are, different things in big data and streaming and open source. Reach out. I'm going to do a couple different data sources, but the simplest one and one that most people are used to is REST data, and it's going to be JSON. Again, I'll show you we could do the same thing as if it was XML, if it was in something like Avro or a text file or logs. The data itself isn't important other than the fact that data is built and generated from events, and I want to get that event into the hands of my data scientists as soon as possible. So as soon as that event starts somewhere, whether that's at a REST endpoint, whether it's a push or a pull, it's in a file, it's in a database, somehow this data exists. It was just created or just updated. I want to get that data. I want to be able to move that through the pipeline as fast as possible, maybe combine that with existing data I have, maybe do updates to it, get it in a format that's clean enough that it can be used for classification or for training. Whatever your needs are, we get that data in. First, we'll show you some stock data. Again, most people are used to seeing stock, so it's not going to be unusual for you. But the nice thing, and I'll show you using these open source tools, is regardless if it's coming from a stock endpoint or it's coming from a device, it's coming from your database, it's coming from a lot of different places, it doesn't matter. It doesn't matter if it's a small file or a large file, a lot of files at once, event at a time. You know, whether it's text, CSV, binary, we could do that with using the same open source tools, and we just have to make some decisions. What do we do with it at the next step? Here I've got first step in our process is usually Apache NiFi. This is an open source tool that you could download, either run in Docker, run in Kubernetes, run in any of the public clouds, run in any of the private clouds, or today I'm just running it on my laptop. And that's really enough that I could crunch a lot of data and then spread that to different sources. I'm going to send it. I have a small cluster running in Amazon. I'm going to use NiFi to clean up the data and get that up into Amazon to do additional processing. And I'll put that in a couple of different open source messaging systems because I need to be able to distribute that to different clients. Because not just data scientists, I might have business analysts who need to put this into a report. It might need to go into a dashboard. It might need to go into a Slack channel. It might go into a mobile application, might go into various data scientist applications. It might go into, just a data store I use for classifications, might go somewhere and just build up some training data. I'll also show you a couple of other open source tools like Apache Kudu, which is a very scalable database that can be used for especially things like time series. And again, time series is just this data that's continuously coming in, but has a timestamp. Some data doesn't have a timestamp. We could use NiFi to add a timestamp as that data comes in. So you have that date. Having dates with your data, unique IDs, are important, even if the data, is created or comes out without that. These are things that help you know when you touch the data, how you changed it, those sort of things. And then we're going to be using Apache Flink. Apache Flink is a very scalable stream processing engine that lets me do things like streaming SQL. This is how we're doing continuous SQL. And continuous SQL means I'm running a SQL query, a new event comes in, that comes into the query. So I could use the query to do things like filter the data, send it to a REST endpoint, make it available as a REST endpoint, put this into a new topic in a messaging system, put this right in a database, maybe join it together, maybe call a machine learning model in something like DGL. So if you have one in Java or Python or Scala or something compiled, or maybe your machine learning is running in something like CML and I have a REST endpoint to call it, or using one of the public cloud providers, REST calls into, pre-built machine learning models, very easy to do. And showing you with more specifics on a particular streaming messaging system. I'm showing you this with Apache Pulsar, and it is one of the upcoming messaging systems. What's cool about this one is there are compatibility layers, so I could just treat it as if it was Kafka or treat it as if it was MQTT or AMQP. It makes it a little easier. You don't have to learn a whole new messaging paradigm. And this one is very scalable and easy to use. But again, when you're distributing the messages, the different Apache open source tools make this pretty easy. And then Flink has connectors to connect to Pulsar or Kafka, or almost anywhere the data needs to be. That's the nice part here is when NiFi is done cleaning it up, I can put it into different data stores or different messaging systems based on my downstream needs. And I could do multiple if I need to, and I'll show you that. Because occasionally you may have a legacy application that needs things to go into a file system or needs to go into Oracle or needs to go into an S3 bucket or needs to go into JMS. We could send it to all those places, let them run independently and still keep our single source of truth somewhere else. But we know we're just sending additional copies without having to change our code, without having to do additional work. Pretty straightforward. Now, I've touched on a couple of these different open source tools, which you could download, start using, whether you want to do it as a regular binary running on your machine or in a VM or a Docker container or Kubernetes. Those are all out there. The first one we're going to touch is Apache NiFi. This one is nice because this lets me do that early ingest curating the data, cleaning it up, deciding how to route it and do that at real time. I can inject machine learning model calls here. I could call classification. I have built-in machine learning models that I can run from NiFi, and I've got articles on a number of ones I've written. I've written some with Apache MXNet, written some with TensorFlow, and I've been using the very revolutionary DJL.ai. If you haven't seen that and you're doing Java, you really need to take a look. This lets you run lots of different deep learning models using Java, and that includes PyTorch, TensorFlow, MXNet, and lets you seamlessly convert between them. That is a really nice thing you can do. NiFi is also nice because sometimes the data is very clean. It comes in a very nicely formatted JSON. There's no extra text in there. There's nothing to convert. That's great. But sometimes your data is binary. What if it comes in a zip file? How are you going to handle that? You're going to write some custom code. You're going to write some custom script. Maybe you write something, there's a cron job over here, and you've got a different kind of schedule over there. And you've got this code sprawl everywhere, and you're trying to figure out how you do this full pipeline, and it's 17 different tools. Some of them are paid. Some of them are a script somewhere. Does anyone understand the whole process? Maybe not. NiFi makes that a lot easier, and it's really easy to get started. I'll show you a lot of that because I think that's one of the key pieces for doing any of these pipelines is making it simple, but still scalable. NiFi can scale out to billions of events a second. So you're not using a tool that's just helpful for small use cases. It's as big as your data needs to go. It can be distributed as much as you want. And again, open source. It's now in version 114. So it is not some kind of new tool that just came out. NiFi has been running for over a decade. And it works with almost any source. If you're missing a source, it's very easy to write your own. If you've done anything like Spring, it's the same, pretty much the same type of development. So you want to add your own machine learning model. You want to write your own source or sink. Very easy to do. I'll show you some of the cool features in there, like the ability to have automatic back pressure, guaranteed delivery, seeing a full lineage of all your data steps as it comes through, which can be helpful when the data scientist says your data didn't look like they expected it, or something goes wrong along the way, especially when you're dealing with maybe 10 or 15 cloud steps. You know, you've got the partner's cloud or the source cloud. You've got, you know, something you're running, and then you've got a couple steps along the way, and your machine learning model is running somewhere else. It's very easy to get lost. Having NiFi lets you know everything that happened along the way, how long it took, how big the data was. I'll show you that when we're running through our demos. What's nice with this is it can be very clean. I've written some articles to show you some best practices. And what's nice with NiFi is if data is binary, just handle it with binary. Maybe it's just a pass through. But if it looks like a database table, I could treat it like a database table. So part of that idea of continuous SQL is I could do some of that SQL conversion at that early step of the ingest before your data becomes something really important. Now, we mentioned messaging and streaming. Apache Pulsar is the new kid on the block here. New is it's been around for a couple of years and it's really stable, but you know it's not as generally widely known as Kafka, JMS, and some of the other ones. But this is a very nice one, open source, and what's nice is cloud native. So if you want to run this in Kubernetes, all the Helm charts are there. You know, there's different hosts out there like Stream Native makes this really easy for you to just use this as a distributed messaging system. And there's a free edition for developers out there. Makes it really nice, very easy to get your events in and out, and with lots of different protocol support. So you don't have to worry about, you know, making every client and producer change to Pulsar. You know, you could use JMS adapters and Kafka adapters. Makes it pretty straightforward. What's nice and what I like about Pulsar is some of these features that, you know, when you get to the point where maybe you've done really well and your machine learning model is used around the world. Well, how am I going to get this data to every one of those models? Maybe I have to train in different countries against a data set that's specific there, or I need to update things, or maybe I'm sharing some of the data, all the data. Pulsar, you start off small with a small local cluster, and then you could geo-replicate without having to, write really complex architecture, without having to put in a lot of extra steps there. It does it for you, and it does it in a really scalable way. You don't have to worry about data stepping on each other. You also don't have to worry about how big do I size these nodes? What happens if I run out of storage? The storage and computer separate, something we've been talking about with cloud for a while. And it also has tiered persistence. So what happens is I've got some stored on that individual bookkeeper node. And then when I get to a certain size, or I could set some conditions, you might not want to ever lose data. I want all the data I ever got. I need it for auditing. I need it for training. This can automatically store that to another persistent store that's cheaper, say S3 buckets, say a file system, say HDFS. Makes that really simple for you to have, some batch data on premise and then, the one that's running through. And as you expect with anything open source, well documented, lots of examples, full REST API, so you could do everything you need that way. Really powerful command line tools to easy hook up with your DevOps process. Ton of different clients. So if you want to use the native protocols, you could do it in Ruby and Python and Java and any of the languages that you're used to. Plus support for existing messaging like MQTT and JMS and Kafka, really popular, very common protocols. You could add Pulsar there and have them interact very straightforward manner. Nice way to do that. Now we say continuous SQL. You could call it streaming analytics. You can call it continuous ETL, call it complex event processing. This is standard SQL. It's powered by Apache Calcite, which is used in things like Phoenix. So it's very standard ANSI 92 SQL. So it's powerful SQL. You don't have to learn really complex, different SQL from what you've seen before. There's a couple of terms you could add for things like windowing of data. So you might want to check on, the last hour of data or the last 15 minutes. All that's in the SQL syntax to make that pretty straightforward. And to show you what some of the SQL looks like before we dive into using one of the Flink SQL interfaces, this is your SQL. It is not any different from what you've saw before, other than things like tumble. Now, these are, like I said, so you can have those windows, because when you're dealing with continuous data, certainly every event that comes in is important, but you might also want to see what's happening in a small subset of that data, like we said, like the last 5 minutes. So I could see things like, hey, are there duplicate payments coming through? Is there duplicate data? Does this look weird? Things like you could do here. And, you could do grouping. You could do aggregates. All the things that you could do with SQL. What's nice as well is that you have some built-in fields come in if you need them. Like for Kafka, you got the partition key, you've got an event timestamp. So you always have this data that you can use. So you could do things, like I said, look at data versus other times, pull apart Avro and JSON to look at individual fields in there, do joins, and not just a simple join like an inner join. You could do left outer join, right outer join, full outer joins. All those things you expect to do in a real rich SQL. This is two of the queries I wrote, and also my cat. I'm looking to, is there a query? No question yet. Thought I saw a question on the chat board. So in Flink SQL, these are some of my examples. I'm going to show you one of the data sets is weather, which is a good source of augmenting a lot of different machine learning, is to have the weather. Weather affects a lot of things, so it's a good extra feature to add there. And here I'm looking at the weather where it's from a certain location. The location isn't empty. And then I've got another query that's doing at stocks, that's doing a hop. And again, similar to that event window, I'm looking at over a certain amount of time, breaking it up into certain chunks and looking at aggregates. Again, lots of different SQL things you can do. And if you're, say, using Pulsar as your messaging, there's nice connection with Flink there. Flink and Pulsar work really well together. I like to call that the flip stack. You see behind me is the flank stack. I've got two cool ideas for using streaming together. One is with Pulsar as a background. One is Kafka. Again, depends on your use case. But if you have a unified batch and stream, Pulsar and Flink make that really easy. And there's some documentation I have here on the Pulsar connector for Flink. And those are some really nice projects for working together on some pretty complex applications where you don't really have to make that decision of, well, if I do batch, I'll do it this way. If it's stream, it's this way. How do I get that batch data and join it with the streams? Makes this a lot simpler. Well, let's look at some actual code. Hopefully my things have not timed out. Sometimes when you're in your slides too long, things will start timing out. So we might have to reload a page, but we'll see. This is the first show of Apache NiFi. Now, if you look at this, you might say, well, this is a nice diagram of your application. It's good to see a diagram. This is not my diagram. This is a live application running on my NiFi node. And I could do things like right-click to see the configuration. Here I could see the schedule that's going on here. This one I have running every number of seconds. It's running every 30 seconds. And this is pulling in from a REST endpoint. This is how easy it is for me to do a REST call. And then I can add some metadata to it as it's coming in. And then here, I'm just going to break apart the records because this REST endpoint gives me, say, 100 or 1,000 records at a time. For my use case, I want to pull apart the way they did JSON. So if we look at the JSON, again, that data lineage or provenance, I see it comes in at 600K. Obviously, that's not going to be one event there. It's going to be a lot. This is all the metadata I have for making my call. So let's look at the actual content. And you can see it's this huge file. But underneath there, I want this value data. This is a subpart of that JSON. Because in here, there's, a few hundred records. And I want those individual records. I don't really care about all the records together. Let me get back to my page. Some preview of all the different things we've got running here, including some visualizations. So yeah, so here, 600K file. You might have to write Python code for that or Java. Lots of complex things you could do. Instead, this one statement in NiFi is going to look at that big JSON file and do an extract of a subpath of that from the values and make new JSON records and apply a schema to them so we know what they're supposed to look like. And here's the start of that SQL. Pretty lame SQL just to select star, but here I could start making decisions on, say, hey, maybe I only want to look at stock where the value is greater than the minimum plus 10, or I don't want to look at stock unless it's over $10. Maybe I've got a strike point. I could set that here. And here, I just look at that JSON. I can convert it to something else. But right now, I want to keep it JSON. If I wanted to convert it to Avro or comma-separated values, whatever your data scientist needs, they often need comma-separated values. We could send it like that. I could send it like Parquet so I could use it in Spark SQL. I can make it XML. I could turn it into a text form. So say you wanted to mail that right to somebody, I could write some free form text and format that nice and give it to them. all in that one step. One thing you'll see that's interesting in NiFi is I just stopped that. I stopped part of my live data pipeline. Nothing's broken, nothing's lost. The record that just came through here, this recent event, is stored in a queue. This is we got another record here. And I could see all the metadata here about that, how it came in, you know, a unique ID on that. And I could just restart that. What's cool is these are configurable queues. I can say how many records it should hold, how much data it can hold, if it should have load balancing, if it should have priority. So maybe you have something that always runs, but then you've got alerts that need to come through quicker. We can easily make those decisions. And here I'm going to update that record. I mentioned for time series, I really want a timestamp. So I'm going to apply one from when I cleaned up and processed that data. This amazingly, the stock data, they didn't put the stock symbol in it. So I'm adding that. I'm adding a timestamp in a different format, and I'm adding a unique ID. And then I'm formatting the timestamp in the way I want. Pretty straightforward. And then I'm making some decisions here. As you can see, I got a lot of data backed up. I wanted to make sure I had enough for the demos. So I've been running this for a while and I paused it. What I'm going to do is I'm going to send the data to a couple different data streams, different formats. For some of my systems like NiFi, Avro is really nice. Avro is a smart format. It's a little smaller than JSON in the semi-binary format, usually has a schema. It's better for queries. So I'm going to convert it to Avro. Again, I could have converted to something else. I'm going to send this to this Kafka topic as Avro, and that's it. That's as hard as it is to send a message into a streaming system where I don't know anything about that data. So there's nothing hard-coded that tells me what the fields are, what their names are, what their types are. This is adaptable. I could have different versions of schemas. Here, I'm splitting it down to make sure I only have one record at a time, because for this system, I want to send one at a time so the data doesn't come through too fast. When we're doing continuous SQL, it can run thousands of messages a second. And if that's the case, you know, it's going to be hard to see what's going on if the data is coming in too quickly. So I'm sending it in a smaller batch. Here I'm sending a bigger batch over here because I don't really care. This is going into NiFi, which is fine with taking 1,000, 10,000 records at a time because I'm going to put that in a data store. So I pushed it into one as single records. And then over here, I'm going to clean up what this looks like. I want to take it out of the format that I have and push it into an attribute so that I can send this through Python to Pulsar. I've got a custom Python script I wrote. I could use a native NiFi processor for this, but I want to communicate with Pulsar via a Python application I wrote. It does some cleanup. It does some special formatting and uses some libraries that I like in Python. So I'm going to call it there. What's nice with NiFi, if you want to call Python applications, very easy. You know, I could have called it via REST, could have called it with some other mechanisms. I'm just going to call it as a command line app because I have this running. I have a script I like. It makes sense for a lot of use cases. So I'm running those there. Obviously, there's a lot of messages coming in through the system, and we'll take a look. We saw that data before. This is where I'm receiving the data. Pretty straightforward. Just reading it from a broker for that specific topic. Again, it came in Avro, pushing it back to JSON. Why'd I even make it Avro? Just to show you different types. Could have kept it JSON, could have converted it to something else. And then here, this doesn't really care because this will have any different reader. So this one is JSON. It reads it, writes it to this table. If you take a look, what's the name of the fields? What's the SQL? I don't know. Doesn't matter. It's looking at it and using the schema, or it can look at the data and infer what it is. It could say, these are what the fields are, these are what the types are, do it for you. So as your data changes, you get new versions, you could just reuse this. And I can make everything a parameter, so I could have this to work with whatever the data is. You subscribe to 20 different stock systems and they give you a slightly different format. Fine. I don't have to change any code. You decide you're going to put your data into Mongo, put your Mongo specifications in here. It's just going to read from JSON, do 100 at a time. That's it. You want to send this to, say, a relational database. Same idea. I could send it to as many places you want, or I could even drag live data there and say, okay, I'm going to instead go to, it's only going to do inserts, and I'm going to create, maybe I'll send it to Postgres, and, maybe I could pick the table based on an attribute and have that dynamic, and then make a couple decisions on what do you do with extra fields that the table doesn't want. Again, makes it very flexible if you're not sure what your data looks like. Or you might say, I don't have any place to put this yet. Let me just drop it in an object store. Or I should do both, You keep that, keep a couple different formats there. Depends on what you're doing. And then if that was the only kind of data we could do, that's pretty powerful. But we could do things like status data. Again, any type of data you have, pretty straightforward. And I could store it in different data stores. I could send it to Slack, which is nice if you're trying to alert data scientists or other people on your team that new data's arrived. And I'll show you when that arrives. A little different is, and this is come in handy for some of my data scientists who are working with data that doesn't always come in the format you want. Lots of public agencies will put it in any format they want. Maybe it's a PDF, it's a Word document, it's zipped, it's coming from an FTP site, all kinds of weirdness that could be a problem for you. It's not a problem for NiFi. Here I'm grabbing all the weather forecasts, all the current observations for the last 15 minutes. They put them in a zip file. That's great. So I grab a zip file, uncompress it, pull that apart, and then throw away a couple of the files I don't want. I'm keeping only the forecast at US airports. And then in this step, converting XML to JSON. I don't really want to work with XML. And I put a little SQL statement in here to do it. I don't want, if it's garbage locations, throw them away. So that's as simple as it is to take a zip file full of XML and convert that into JSON that I'm going to send as live data here. And I could validate the record. As you see, some of them didn't make it. So I looked at this JSON data, compared it against a schema that I want. There's certain basic fields I have to have. I want the temperature, I want the wind speed, I want humidity, I want location. If you don't have that, throw it away. You could have some extra fields and maybe I'll ignore them. Maybe the types are, maybe it's a string, it should be an int, I could cast that later. Couple of different things here, but if it's real junk, throw it away. Maybe I could decide what I want to do with that later. Maybe I'm going to put that in a S3 bucket and analyze that later. Here I'm sending it to a couple different Kafka topics, some of them in a batch, some of them event at a time. Pretty straightforward to do. Some of the data I'm sending into Pulsar. Just wanted to show you a very easy way to do that. I can run this in Kubernetes or Docker or on my local PC, but the Stream Native Cloud gives me a free place to run a small cluster. And I set one up to have my topic here and just get these messages. Very easy way to do that. gives you one place to monitor, manage that. Pretty straightforward. But since there is that free tier, this is a good way to explore with Apache Pulsar without having to, set up your development system and have all that build tools there. Keeping it cloud native is nice. We talked about schemas. Schemas are nice to have. I could do schemas in Stream Native as part of Pulsar. For Kafka, I've got to use a separate registry for that. This registry has, like for this specific stock type, it's got all the fields. This is helpful. If this changes, I had a new version, I add a new field. Maybe whatever your changes you're making to different versions of your data, you put it here. You pick your type, maybe you put a little document there. This one was auto-generated for me. This one has different values in here. Again, it's slightly different from the other type of stocks. And the weather one is a little different as well. Just to give you an idea, different things. Is it nullable? Different types. This one's a double. Makes it so you can automatically have that SQL. Makes it pretty straightforward. Like how we were monitoring Pulsar, we could also manage Kafka. Pretty straightforward here. Just run into this clutter SMM. This will let me monitor the data. Remember I said Avro? Sometimes it's Avro. Well, the flaw with Avro is it's not very clean. Fortunately, this tool here lets me look at it as if it was JSON. Again, remember I added a couple fields. I added symbol. I added a unique ID. I added a timestamp. I added a date time. So the data scientist said, yeah, it's nice you have a timestamp, but I don't want to have to convert that from Unix format every time. Give me one I can easily see. So I added the date time. So you have a nice formatted date there. Then you got the different values of the stock. And then that just goes over time. I put a unique key ID and there's unique timestamp and there's an offset. So if I want to find this data, makes it very easy for me to, someone says, hey, I didn't get the data. I can look in NiFi. I can look in my monitoring and can see everything is there. If something's missing, we'll know right away. Very straightforward. Now, continuous SQL, let's finally show you some continuous SQL. So as data comes in, it shows up here. This is my very advanced place that I'm running my SQL. About the simplest SQL you can have, just select from a table. But the secret here is it's not a table. Behind the scenes, this table, if I look at the DDL that it created for me, is a topic in a messaging system. And there's some parameters there, what format it is, what the topic is, how I'm reading it, and put some automatic fields in there for me. Pretty straightforward. And I could have a ton of other ones I could automatically bring in. I could also write custom functions. I could see every query that I've run. I could see all the different SQL jobs that I'm running. So if I need to manage that, very straightforward. Now, to get all that data, I've got a connection to my messaging brokers. I also have some catalogs, so I know what the data looks like. And these are really easy to add. Press a button, give it a name, pick a type, put the URL there, and then it'll validate it. It automatically import all your tables. I mentioned that REST endpoint. I know we're getting low on time. I didn't see any questions. Yeah, I'll post all the links to different things in there if you need to see more data. But that link is important because I can use that in here to be able to see that within a regular REST client. I could also look at my data in as a query. So we see that data stored. I could also send that to Slack. Again, this is a very easy way to communicate with the team. I could send a sample of the data, or I could send every piece of data if you don't have too much here. So I'm sending all that weather data to Slack so someone could see, yeah, you really need to add another field, or you don't need this field, or yeah, that's the data I want. And then they could subscribe to that, whether through messaging or through a data store or through somewhere else. And I can also send that data to a report. So you got, as that data comes in continuously, I could put it on a map. And this is where I live in lovely New Jersey, next to New York City. You can see we've got a lot of different weather reports. These are coming in from different airports. Pretty straightforward, but very easy to start using this data from whatever process you need there. If I'm running low on time, please let me know. I believe we have till 10:45. I don't see any questions on any of the chats. Hopefully I haven't missed any of the chat systems. I don't want to miss anything of interest, but you'll have the this video, you'll have the slides, and we've got links into how to run these apps on your own. That REST endpoint that Flink was pushing out, I pulled that into a visualization. I could also pull that into Jupyter Notebook. As you see, it's a JSON array. Very easy to process that in Python or in R and do whatever kind of analytics you need to do on that, or feed that into your model. Again, very easy to work with this data. Hopefully you've liked this talk. Not too many comments there, but that's fine. Thanks for the comments on the cats. Yes, what's the question?
No question from me. It's just I want to tell that your talk is very insightful. We have a different tool set in our project, so just looking at the different ways to organize the things and different ways to approach to the problems is very insightful. Thank you for this. Guys, any questions? Probably any comments you have while we still have Tim?
And I'm in the Telegram group, so feel free, if something comes up later, just put it in there. I'll get a notification and I'll do something there. Not a worry.